2013 Paper 1 Sequences and Series. This is on question 8 this year. So it looks like a financial maths question, but actually it's sequences and series. Two brothers, Owen and Peter, began work in 2005 at starting salaries of 20,000 and 17,000 per annum respectively. Owen's salary increased by €500 per annum and Peter's salary increased it by €1,250 per annum. This salary pattern will continue. Complete the table showing the annual salary of each brother for the year 2005 to 2010. So they ask you to fill in the table. So it's fairly straightforward. We know Owen's salary increases by 500, so you're adding 500 all the way across until year 6. And Peter's salary increasing by 1,250, so we add that across here. Okay, in what year will both brothers earn the same amount? Well, I know it's starting at 2005, so I put 2005 there at year 1, and then just in red writing there 2006, 2007, 2008, 2009, 2010. And we can see 2009, they both have €22,000 each. So 2009 is our answer. Owen claims that their salaries over the years can be represented by an arithmetic sequence. Explain what an arithmetic sequence is. Arithmetic sequence is a linear sequence. What the answer in the back of the exam paper says is a sequence in which the difference between any two successive terms is constant, but the way that we have talked about it is it's a sequence where the first difference between each term is the same. And then they say, do you agree with Owen? And yes, as there is a common difference between each year. Is that okay? So there's a common difference of 500 here and a common difference of 1,250 here. Find in terms of n a formula that gives Owen's salary in the nth year of the pattern. So this time they're actually looking for T of n. That's what they're asking for there. So we use our formula. T of n is equal to A plus n minus 2 times D. We know that A is 20,000 starting off for Owen. We know the common difference is 500. So we've got 20,000 for A and the common difference of D, 500 for D. So A plus, move your D over here, n minus 1. So 20,000 plus D is 500, n minus 1. Multiplying out the brackets, T of n is equal to 20,000 plus 500 n minus 500. T of n is equal to 19,500 and 500 n. Moving on to part E. Using your formula or otherwise, find Owen's salary in the year 2015. Now, the way I figured out what year 2015 was I just know year 6 is 2010. So I just did 2010, 2011, 2012, 13, 2014, 2015, year 6, 7, 8, 9, 10, and it turns out in 2015 it's year 11. Therefore, it's N11. I'm going to use the formula I've worked out already above. T of n is equal to 19,500 plus 500 n. T11 then, sub N11 here, and you should get 25,000. Moving over to part F. Find in terms of n a formula that gives the total amount earned by Peter from the first to the nth of year of the pattern. So when you see the word total, that should automatically make you think of the S of n. So we're now talking about Peter. So Peter starts off at 17,000. So that is going to be his A. A is 17,000, and we know there's a difference of 1,250 between each of them. So we're going to use our formula from the formula tables. N all over 2 times A plus, I've put my D in front of the brackets here already, D brackets N minus 1. 2 sets of brackets just so that you can see clearly which goes with which. Subbing in A, 17,000 here, and D, 1,250. Multiplying out two 17,000s, 34,000. 1,250 N minus 1,250. Put them together, you've got 32,750. How do we deal with this? This is a little bit tricky. So n all over 2. So the first thing I did was I brought my 2 in. So my 2 the half, basically. The half goes in underneath each individual number there inside the brackets. 2 into 32,750 goes 16,375, and 2 into 1,250 goes 625. Now I'm left then just on the outside, so just multiply out the brackets. I moved my squared to the beginning of the expression. It's just the normal way that we write it. So 625n plus 1,637, 16,375n. Part G. Use your formula or otherwise. Find the total amount earned by Peter from the start of year 2005 up to the end of 2015. So from part E on the previous page, we know that the year 2015 is N11. Now, as I've saying there, it's much easier just to use the formula we've already worked out here rather than starting from the beginning. But you could start at the beginning using this formula here if you wanted to. But again, much easier to work from this. So now that I've got my formula, all I have to do is sub in S11. So N is 11, sub in 11 here and 11 here. Multiply them all out with your calculator and you get 255,750. Last part then, H. Give one reason why the graph below is not an accurate way to represent Peter's salary over the period. Peter's salary increases in steps, not gradually as shown. So that means that not every day does Peter get a tiny little increase. It's at the end of his first year then does he get his increase, and the end of the next year then he gets his increase. So it should actually go up in steps like we've seen there at the bottom half of the graph.